User interfaces are our windows into our digital devices. Today we talk about their evolution and how we got to these amazing touchscreen devices that we have today. Welcome to Kopec Explains Software, the podcast where we make computing intelligible.
Okay, Dave, for this week, how have UIs evolved?
And a UI, of course, is a user interface. What does the word user interface or the term user interface mean to you?
How do I interact with whatever I'm interacting with?
Yeah, it's our interaction model, and there's many different interaction models. Our listeners might have heard of things like command line interfaces, graphical user interfaces, or of course, voice interfaces, which are becoming so prevalent today. So where should we start?
I guess at the beginning, how did these evolve? What was it like when computers were first being used?
When computers first came out in the 1940s and 1950s, it was very primitive. So we're talking about people physically manipulating switches and dials to actually input information into the computer and then getting switches turning or individual lights coming on or off to see output coming back from the computer. Very, very primitive. We're going to mainly focus on this episode on personal computers, but going back before personal computers, looking into the 50s, 60s, 70s, what evolved was punch card interfaces, where people would input their programs by physically making holes in cards that would go through card readers, and then eventually there would be different ordering to these cards, and some people's cards might get read before other people's cards, and so you might actually wait minutes or in some cases even hours for the stacks of cards to get processed, and eventually you might get some kind of printout somewhere else that has the results of your program. So there wasn't this kind of instantaneous loop where you make some input and you immediately get some output back. Back in the day, it was you physically made this card and then you waited maybe even for minutes or hours to get some kind of printout back from your card. It wasn't like you were sitting in front of a monitor. It wasn't like you were using a keyboard in the same way that we think about a keyboard today.
So we went from punch cards to what?
To command line interfaces. And now I'm going to talk mainly just about personal computers from this point forward. And for people who don't know about the personal computer revolution, they can check out our previous episode on the personal computer revolution, which I'll put a link to in the show notes. But the personal computer revolution gets started in the mid-1970s, and all the first personal computers are already at the point of having video displays and keyboards. And so what that means is users can do their input just typing on a keyboard, which is much easier than creating a punch card, and they can get instantaneous output on the video monitor in front of them. And oftentimes, as we talked about in that previous episode, that would be actually a television, but it might be something that's specifically a computer monitor. But you're typing on your keyboard and you're getting instantaneous output on your monitor. But the way you're getting that input in is through using commands. So do you know what a command line interface is, Rebecca?
It's where you don't click on things, but you get to type and tell the computer to do stuff.
Right. Everything is typed out. And so I'm sure you've seen me use what's called the terminal program on my Mac. And that's just another way of communicating with the computer instead of clicking on icons, pulling things out of menus, or using buttons. Instead, we're actually literally writing every command that we want the computer to do out on the keyboard. You can almost think about it, for people who've never used a command line interface, as like texting with your computer. You're texting it some kind of command and it's giving you text output back as a reply. And so this is the main interaction model for computing through the 70s, 80s, and even into the early 90s. Although already in the 80s and 70s, we're starting to see alternatives. But for people who grew up back in the 80s, early 90s, or even a little bit before that, you're probably familiar with IBM's PC computers, and a lot of them ran Microsoft's DOS operating system. And DOS was a command line interface, and it was the most popular command line interface for a very long time. But early computers, even before the IBM PC, like we talked about in that previous episode, like the Apple II or the TRS-80 or the Commodore 64, all also had command line interfaces. So this was the main interaction model with your computer. Today, basically people who are programmers, system administrators, we're the main ones who still use command line interfaces. Very rarely would a regular user use a computer today that has a command line interface.
How come?
Because we just found easier and better interfaces for everyday users, interfaces that were easier to use. When you use a command line interface, A, it's not as interactive because it's not graphical, but B, you also have to memorize a lot of the commands or at least look them up every time you want to run them. With a graphical user interface, which we'll get into next, you can instantly see what your options are and see what you can do without having to know exactly what to write.
So graphical interfaces make things more accessible.
They make things more accessible, absolutely. And graphical user interfaces were not a new idea when they first got commercialized, but it took a while. It took about 15 years for them to go from idea to commercialization.
And when we say graphical, what we mean is like visual icons, that you're not specifically writing the command you want, but that you have something like an icon for the program you want to run.
Right, you have all kinds of iconography. You have buttons, you have checkboxes, you have menus, you have text entry boxes, you have labels, et cetera, et cetera, et cetera. Mm-hmm. There's a lot of different what we call widgets in a graphical user interface. The first person who really showcased the possibility of this and an interaction model with a mouse for them was Douglas Engelbart, and he gave what was called the mother of all demos in 1968. This is about 15 years before we had the first mass-produced, popular graphical user interface computer. He's already showcasing all this stuff. He was way ahead of his time, which is why it's called the mother of all demos. And he also showed a lot of other really interesting stuff that eventually became commonplace. But the first computer to have a graphical user interface that was sold commercially and was available was not that long after. It was in 1973. It was a Xerox Alto, but it was way too expensive. And it was just not accessible to your everyday computer user. This was before even the personal computer revolution. This was supposed to be a business computer, but it cost so much money, even small businesses couldn't afford it. So the personal computer revolution happens. We have all these command line interfaces. And then in the early 80s to mid 1980s, there's a race to be the first popular graphical user interface.
And who was that?
So the first mass-produced, affordable graphical user interface computer was really the Apple Macintosh. And it comes out in 1984. But nipping on its heels are a lot of competitors. In fact, Microsoft's main competitor to this, which was Microsoft Windows, of course, 1.0 comes out in 1985, 1 year later. And, both of them had been inspired by the Xerox Alto and the Xerox Star, which was another Xerox computer that came after that. It wasn't like they came up with all these ideas, but they did make refinements. So there were certain additional widgets that existed in the first Apple Macintosh that hadn't existed in the Xerox machine. So they were certainly inspired by Xerox, but they also were making some improvements as well to what Xerox had done. But maybe the number one improvement they were making was making this affordable. So making it so that average consumer could actually get a machine with a graphical user interface.
So this is when computers start to really look like, with the graphical user interface, what we now just take for granted and expect our computers to look like.
Right. And it might surprise you to know that people were not 100% convinced at first that this was definitely going to be the future. And it took a while for all computers to have graphical user interface, all personal computers to have graphical user interfaces. IBM's PCs and all of their clones continued to ship with Microsoft DOS into the mid-1990s. And Microsoft Windows didn't really break out and become a de facto standard on top of DOS until the early 1990s in Microsoft Windows 3 and Microsoft Windows 3.1. So it took quite a while, actually, between when these first graphical user interface personal computers come out till they become ubiquitous. But then we had graphical user interfaces all the way up to today. When you use your PC or you use your Mac, the general user interaction model that you're using is a graphical user interface. And it's not that different. I think a user using that original Macintosh in 1984 would be able to figure out how to navigate a modern Windows or Mac computer in 2020.
So we're now, graphical user interfaces are kind of the standard. We're all using that. Where do we go from here? What's the next user interface?
Well, the next real interaction paradigm that becomes commonplace is touch. And touch is really still working with a graphical user interface, but we're replacing the mouse with at first the stylus and later on the finger. And, we had popular touchscreen computers going back to the 1990s. This was the PDA revolution. So these are things like the Palm Pilot, or before that even the Apple Newton, or the first Microsoft Pocket PCs. these all had touchscreen interfaces. They usually had a stylus, but it was still really the same kind of widgets as we have in graphical user interfaces on PCs. But what we were getting was a new paradigm for interacting with those graphical user interfaces in the form of the stylus and later on your finger. Now, PDAs, again, they came after touchscreens being invented back in the 70s and 80s. It wasn't like they invented the idea of the touchscreen. But like with the Macintosh, what the Palm Pilot and its compatriots did was make the technology more affordable and more accessible to a wider audience. So that's what we got in the 90s. But then in the 2000s, we really took touch to the next level.
Well, what happens? How does it go to the next level?
It goes to the next level really with the iPhone. When the original iPhone comes out in 2007, it introduced a new kind of touch called multi-touch. And this was actually started at a small startup company that Apple had purchased and then evolved into the interface for the iPhone. And multi-touch was revolutionary because it didn't just allow you to use one finger or one stylus at a time. It allowed you to use multiple fingers and do what are called gestures. So what are some common gestures that you do on your phone or on your tablet all the time?
It's like pinching, zooming out.
Right. Swiping,
yeah.
Absolutely. So these kind of multi-touch gestures were not possible on earlier touchscreen devices, and they're actually a combination of hardware and software technology to make them possible. But that was really a revolutionary user interface when the first iPhone came out. And when they were developing the first Android devices, they were thinking about them more as having a model more like the BlackBerry, where you'd have like a little chiclet keyboard underneath the bottom of the screen. But when the iPhone came out with multi-touch, everyone saw, wow, this is so much better than any of the paradigms we'd had before on small devices. And so when Android came out a year later in 2008, they of course went to multi-touch as well. And so that's all history now, and all smartphone devices and basically all tablets today are multi-touch devices. And that's the expectation of consumers.
So multi-touch, now we can do really cool things on our small devices. Where do we go from here?
Yeah, and I want to say I'd still call multi-touch a graphical user interface because, again, we're still having those same widgets. Even on our smartphones or our tablets, we still have buttons, we still have menus, we still have a lot of the same selection of widgets as we had with the Macintosh, with Windows, or with those PDAs in the 1990s. But where we go next is voice, and this has also been really leveled up by smartphones. In that voice interfaces, again, have existed for decades. But it's really with the smartphone and some other accompanying technologies that have happened to risen the last decade or so that voice interfaces have really become commonplace. And when I say voice interface, I mean literally talking to your device. This is something that was possible in the past but didn't work very well. And it's really only started to work really well in the last 10 years or so.
So we're talking about Apple's Siri or Amazon's Alexa.
Right, or Microsoft's Cortana or Google Now from Google. We're talking about we say a command and then we get some interaction back, and it may be something that we see on our computer or it may be spoken back to us. And voice interfaces really rely on a lot of pretty advanced machine learning technology to really work well. And there has been a renaissance. If you listen to our previous episode on artificial intelligence, you'll hear a little bit more about this. But there's been a renaissance in machine learning the last 10 years. There's been a renaissance in neural networks and what's called deep learning. And this has really improved voice recognition and natural language understanding and really enabled these interfaces. But we also needed fast enough hardware to do the processing. So again, just like the graphical user interface and multi-touch, the enablers of voice technology have been a combination of hardware and software technology. Faster hardware capable of doing more processing in a shorter amount of time, and improved software techniques coming from things like deep learning to really make voice interfaces possible. But we're really seeing them become not just another window into our existing devices, but we're seeing whole new devices formed, of course, around voice interfaces. You think about something like the Amazon Echo or the Apple HomePod. These are hardware devices that are wholly based around voice interfaces.
So we're talking now to our devices, but what happens next? I guess it's the follow-up question. Where are user interfaces, or how are they being developed? What do you think the future of them will be?
Well, so the speculation, and there has been some research and some real things happening in this area, is neural interfaces. And so, of course, the very in the media company working on this, startup company, is Neuralink from Elon Musk. They're working on literally having a chip. embedded into your brain that'll allow you to communicate with a computing device.
I feel like I've seen that sci-fi movie.
Oh, yeah. And this is a lot of these things, were sci-fi before they became reality. So voice interfaces, for example, right? If you look at the movie 2001, A Space Odyssey, which I think came out in like 1969, they already had a voice interface to the computer on the ship. And so did Star Trek, of course, going back to the 1960s. And it took, a lot of times things come out first in science fiction before they become reality. But if you look at kind of what those voice interfaces were like in those shows, we're not that far off when you use Siri or you use Alexa from something like that. It's not quite as intelligent, but then again, they were looking, in Star Trek's case at least, centuries from now. 2001, A Space Odyssey, they were a little bit off in terms of their timing. But it's certainly possible, and we have voice interfaces that are not inconceivably far from where those sci-fi movies were. So neural interfaces, is it possible? Based on the research I've seen and a few papers I've read, I would say yes, it's certainly possible. Is it likely in the near future? In my estimation, probably not. I'd say there might be primitive neural interfaces, certainly things that can help people with disabilities. But in terms of like being able to download computing information into your brain, I think that's quite a ways off. I think what's more likely is the ability to maybe control, and we already have this. There already are research projects and commercial projects that can do this. But the ability to control, let's say, your mouse pointer with your brain, or maybe even get to the point of being able to think some words and the words show up. I don't think that's an impossibility within the next couple decades, but I think being able to download computing information into your brain, based on at least what I've seen, I think that's probably pretty far off. So when we talk about user interfaces, we're talking about both input and output. Input is what you're putting into the computer. Output is what you're getting back. The limitation for us as humans is actually on both ends, right? Here's the limitation. For input, we're limited by how fast we can type or how fast we can talk. If it's a command line interface, then it's how fast we can type. If it's a graphical user interface, it's how fast we can click and how fast we can type. If it's a voice interface, it's how fast we can talk, right? But we might actually think as human beings. We're able to think sometimes a lot faster than we can type or a lot faster than we can talk. And so that's a real bottleneck. In terms of us getting information into the computer, it's a bottleneck that we're limited by these physical things instead of the abilities of our brain. Now, when we think the other way, when we think output, we're actually a little better at that as far as getting some good bandwidth. Because when we, they say an image is worth 1,000 words, right? Well, we can usually read faster than we can type or we can talk, but we can see images even faster than we can read, and we can watch movies and get input into our brain faster than we can even type or talk as well, right? So if you think about like what would really help us work with computers, right? The output is not such a big problem because we can read and watch movies pretty fast. The input is really the problem, that we're limited by our ability to type and our ability to talk. And so if we could get neural interfaces just that go that one direction, just that I could think and so I don't have to type, or I could think so I don't have to move the mouse, that would really greatly increase our ability to be at the same speed that we're getting input and output out of the machine. So even if we just got neural interfaces to the point where we can control the machine, but it's not actually downloading information into our brain, that would really take us a long way, in my opinion.
Well, right now we have VR and AR. So how does that tie into user interfaces?
Yeah, so VR and AR there's been excitement around them for quite a while. If we look at virtual reality, there was already virtual reality systems in the 80s. There were already commercial ones in the 90s. You think about something like the Nintendo Virtual Boy. It was a big flop video game system from the mid-1990s. It's been available. We're now seeing devices for the first time that have shipped millions of units. You think about something like the company Oculus, or you think about some of the things that Samsung has come out with, and certainly we're seeing VR devices that are getting some kind of traction. But there was a lot of people saying a few years ago that this was going to be the total next paradigm, and that's not 100% clear. Like we're certainly seeing traction, but there's a difference between traction and displacement. The graphical user interface totally displaced the command line interface. As we see it so far, it doesn't look like virtual reality is going to totally displace the graphical user interface because we already have viable devices and it hasn't. So I'm not sure that that's going to happen. Augmented reality I think is, like the term, going to be an augmentation on these existing interfaces. So what's augmented reality? So virtual reality is having a totally different world that you can jump into. Augmented reality is adding additional overlays to your existing world. And, we already have had examples of this for a while. You look at the Yelp app. So when Yelp came out in 2010 or 2009 with the Yelp monocle on their iPhone app, it allowed you to browse the street with your camera on your phone and see overlays of star ratings and restaurant names on top of where you're looking around. And believe it or not, that was created by an intern at Yelp in his spare time. And then it actually became something shipped with the product. But they actually discontinued the Yelp monocle a couple of years ago. So these AR interfaces have kind of come and gone. And it's not clear again that they offer enough value that people really want to jump into them. Another version is Google Glass. Google Glass came out in beta form more than half a decade ago. But again, Google actually didn't follow it up with a mainstream device. They're still, I think, selling it to enterprises because it didn't catch fire, and it didn't just show that it was obviously going to displace the graphical user interface, the voice interface, and the touch interface that we've already had. So I think augmented reality is going to be more and more common as an additional option in apps that we have, but I don't see it just immediately displacing all these other interfaces that we already have. That's at least my opinion.
All right. So user interfaces, the way that we connect with and use our devices, has been evolving from the very beginning to become more and more accessible and user-friendly in a lot of ways. Anything else our listeners should know about UIs?
I think that modern UI is a combination of art and science. We haven't even talked about how graphical user interfaces have evolved over time, where they started out being more like what we expect from the real world. So you have a little trash can on your computer when you want to delete something, and you have some maybe leather on your address book when you want to know that it's an address book, to our modern very flat designs that are more and more just fully immersed in the digitalness of themselves instead of being callbacks to the real world. They've evolved in many ways, and I don't see them as slowing down, but I do see that there's certain interaction paradigms that make more sense for certain kind of tasks. So there's some times where it makes more sense to do something through voice or do something through a graphical user interface. And there's sometimes that it might even make more sense to do something through a command line interface. And so I think instead of seeing the mass displacement as we saw in the past, I think what we're more going to see is a combination of interfaces, the right interface being used for the right task. So I don't think it's just so much about asking what's next as it is asking what can be added, what can be combined to have a more interactive and enmeshed experience for the user. All right. Well, we really appreciate everybody listening this week. Don't forget to follow us on Twitter. What's our Twitter username, Rebecca?
Kopec Explains.
Which is?
KOPECEXPLAINS.
And don't forget to leave us a review on your podcast player of choice, whether that be Overcast, and you leave us a little star, Apple Podcasts, and you leave us a full review and rate us 5 stars. We really appreciate that. Or if you just follow us on Spotify, it really helps get our show noticed. And we look forward to seeing you next week.
Thanks for listening.